Hello everybody. We now are going to start with the practical chemistry part of chemistry. Now this actually is not a chapter as such, but somehow I feel that it is very important. This is because if you know these things properly, then you can identify the compounds more easily, and it is going to be it's something like a basic knowledge of chemistry. So practical chemistry, of course, in this situation of COVID, you are not going to do these practicals yourself, and that's why it is better that you understand those things properly. So in the practical chemistry, the major thing what is you need to understand is the part about identification of the gases. So first thing is the different gases. They are given over here in the last pages of the chapter, in the part that is practical chemistry chart karke hai. That is from so in that case they are given totally 10 different gases which can be identified by some test or some kind of we can say the color of the fumes, etc. And then there are around action of heat for around 10 different chemicals. So compounds, 10 different chemicals, when they are heated, what will be the action of heat part? So that is the 10 part. And then finally is what will happen when a metal is going to be metal like a carbonate, so when it is reacted with an acid. So when an dilute sulfuric acid is added to it, then what will be the reaction like is the third part. Along with it will also be the flame test, which the color of the flame will identify the metal present in that salt. So that is the part we are going to do. Hard water sulfur, anyway it's cancelled from the syllabus, so we are not going to go through that. And of course then are the colored pages. The colored pages are just for your understanding के जो हम लोग ने देखा उधर, जो हम लोग ने पढ़ा उधर, उसको हम लोग यहाँ पे अगर देखेंगे तो कैसा दिखेगा. So and pollution also is cancelled, so you need not do that part. So we are just going to go through the three parts. That is the identification of gases, the 10 gases which are given over here. Then the heating effect of the 10 different chemicals, that is the compounds. Heating से क्या होगा? So what happens when के लिए बहुत important है वो. And finally is what happens to the metals or salts when they are added with dilute sulfuric acid. So let's start with the first thing, and that is the neutral gases. So the neutral gases, there are three neutral gases over here. One is the water vapor, the second is hydrogen, and the third being oxygen. Now in this chapter, whatever the equations are given to you, need not learn these equations. इसका ज़रूरत नहीं है, because they are just for your understanding. So these are not going to be required to be learned as such. But yes, you should know exactly कि क्या हुआ उसके अंदर, so that you can identify the gases properly. The first is water vapor. Now we can see the water vapor if you want to try that, because they are neutral. So litmus paper, when you are going to take, they are neutral to litmus. That means the red will remain red or the blue will remain blue. So that's why neutral to litmus paper. The second is that the color will be colorless and odor is odorless. So we cannot identify them by the color and the odor. But main thing is that if you take a cube copper sulfate anhydrous copper sulfate, which is white colored powder. So a white colored powder copper sulfate is taken. If you add some few drops of this water vapor, then it is going to turn into blue colored crystal. So that's why the white CuSO4 plus 5H2O is going to turn into blue colored CuSO4 dot 5H2O. So that is the main test. So white color copper sulfate powder turns to blue crystals. That is the test for water vapor. Another test for water vapor is cobalt chloride paper. The blue color cobalt chloride paper turns pink when it comes in contact with water. So cobalt chloride paper blue turns pink with water. The second gas is hydrogen. Again, it is colorless and odorless, so you cannot identify the hydrogen by its color or odor. It again neutral to litmus, so new litmus test. But what happens is, the test will be if you bring a burning wooden splinter, then the gas extinguishes the splinter. So hydrogen extinguishes the burning splinter. This is because hydrogen is non-combustible. But when hydrogen is going to be burned in presence of air, it burns in a pale blue flame. So the test for hydrogen will be burns with a pale blue flame and a pop sound. Okay, it burns with a pop sound and a pale blue flame. So that is the kind of the identification of hydrogen gas. So hydrogen gas कभी भी कोई भी जगह पे hydrogen gas generate हो रहा है and you want to identify it, it is going to be when you burn it in oxygen in presence of air, it is going to burn with a pale blue flame and with a pop sound. The next is oxygen. Very simple. Again, they are neutral. They are colorless, odorless. So the test will be, yes, you bring a glowing splinter and you bring it inside the oxygen, it glows. So rekindles. It is going to rekindle a glowing wooden splinter. That means अगर हम लोग ने एक अगरबत्ती लिया जो normally सिर्फ वो जल रहा है, it is not into flames. So if you take that agarbatti and put it inside oxygen, it is going to start catching fire. No? Fire जैसा हो जाएगा. It will be rekindled. And secondly is if you are going to do some kind of experiment over there, then you know that colorless alkaline pyrogolal, okay, colorless alkaline pyrogolal solution turns brown in presence of oxygen. So colorless pyrogolal is going to turn into brown color. So that is the test for oxygen. So these were the three things for the neutral gases: water vapor, hydrogen and oxygen. The next one we have are the acidic gases. What are acidic gases? Those gases which then they react with water, film and forms an acid are acidic gases. Okay, so that's why it will be carbon dioxide will be the first one. So carbon dioxide, it is colorless and odorless, so you cannot identify the carbon dioxide by its color or odor, but it is going to be when you are going to bring a moist litmus paper over there, then the blue litmus paper will turn slightly red. Okay, it will be turn faint red. Faint red Q, because the acid, carbonic acid which is formed is only slightly acidic in nature. That's why it is going to turn into faint red. So how do you distinguish it? So basically features में test में क्या है? सबसे पहले तो क्या है? So burning wooden splinter लेके आए. Carbon dioxide is the fire extinguisher, so it extinguishes the fire. So extinguishes by the carbon dioxide. So as soon as you bring that glowing splinter and put it in carbon dioxide, it will go off. Another thing is that carbon dioxide, when it comes in contact with lime water is nothing but calcium hydroxide. So CaOH, calcium hydroxide, when it comes in contact with carbon dioxide, it is going to form into calcium carbonate, and this is white colored PPT. That's why it turns lime water milky. Okay, so lime water is going to turn milky when carbon dioxide is passed through it. So the milkiness, and if you put some more amount of carbon dioxide into it, then it is going to the milkiness is going to get removed, because the carbon dioxide excess होने के कारण तो carbonate बना था वो bicarbonate बन जाएगा, and bicarbonate is soluble. That's why it is going to be having no PPT. So first thing is that if you take the lime water and you put carbon dioxide, it will turn milky. But after you put some more acid, more of gas into it, it will again turn colorless because of the formation of the bicarbonate. And secondly is the test में, if I take a KMnO4 paper or K2Cr2O7 paper or solution, that is potassium dichromate solution or potassium permanganate solution, it will have no effect with carbon dioxide. The carbon dioxide will not change the color of the solution at all. So there is no change or no effect of KMnO4 or K2Cr2O7 with CO2. So that was the distribution feature of CO2, carbon dioxide. The next we see is sulfur dioxide. Now sulfur dioxide is colorless, but it has got a burning sulfur. It's got a suffocating odor. Okay, so it's got a slight suffocating odor which can identify it. But suppose हम लोगों को odor नहीं समझ में आया, तो we need to understand the test. So again, it will turn the moist litmus paper red. So blue litmus turns red. So that is one more important thing, but many of them can do that thing, so we cannot identify it this way. So what you do is again get the glowing splinter and put it over there. So if you burning splinter, if you wooden splinter, if you bring over there, you will find that it extinguishes. So sulfur dioxide extinguishes the fire. And second is that it is seen that even over here, SO2, when you are going to pass it through lime water, it is going to turn the lime water milky. So lime water turns milky by both carbon dioxide as well as sulfur dioxide. So if lime water turns milky, we cannot just say that it is carbon dioxide or it is sulfur dioxide. You will have to do some further test. So first thing is that both of them are going to turn milky, and again the same way, if I am going to put some excess of SO2, it will turn into bisulfide, and that's why it is not going to have any sign of milkiness. So the milkiness is going to disappear if I put some excess amount of SO2 into it. That's the reason that the test wise, agar milky wise ka agar dikhna hai to whether it is SO2 or CO2, you will find that the both are going to have the similar kind of observation. That's why you cannot identify CO2 or SO2 by this test. The other test which can help you is the KMnO4 and K2Cr2. We had studied that CO2 has no effect on K2Cr2 or KMnO4 solution, but here you will see that the acidified potassium permanganate solution turns from pink to clear color. Okay, the pink color, the KMnO4, that is potassium permanganate, will turn into clear color, whereas the acidified potassium dichromate, that is orange color, will become clear green. So this shows that the identification of CO2 and SO2 के लिए important ये होगा कि अगर lime water turn milky हो रहा है तो या CO2 या SO2 तो है, पर उन दोनों में से कौन सा है उसके लिए we will take either KMnO4, where if the pink color turns clear then it is SO2, if there is no change then it is CO2. वैसे ही K2Cr2O7, if it is orange in color और उसमें अगर green हो गया तो it is SO2, अगर कुछ change नहीं हुआ तो it is CO2. So this was the acidic gas number 5. Now we are going to acidic gas number 6, that is chlorine. So chlorine, सबसे पहले you can easily identify it by the color because of the greenish yellow color. The greenish yellow color of the chlorine and the pungent odor will automatically identify chlorine easily. But of course, certain times we need a test for identification. The odor and taste and odor and the color and all may not help you. So that's why we need to understand this also, the process of testing also. So first is the blue litmus turn. Now here a very important thing. A blue litmus paper is going to turn red and then it is going to bleach, because chlorine is a bleaching agent, so the color vanishes. There is no blue now, it becomes white. So that is why it gets bleached. So the blue turns red and then gets bleached is the very important kind of observation in case of chlorine gas. Otherwise, what you can see that the turn blue litmus red and then bleaches it because of the decolorization. And another thing is that moist starch iodide paper, Ki, that is moist starch iodide paper, is going to turn blue black. Okay, this is the test for chlorine, that moist starch iodide paper is going to turn blue black. So that is the test for chlorine. The next test is for hydrogen chloride, HCl. Hydrogen chloride, the color is colorless but the odor is pungent. So, and of course it is going to turn the blue litmus red. So that is the test for hydrogen chloride, but the main test for hydrogen chloride will be with the help of ammonia. So you can see that when you are bringing a glass rod dipped in ammonia solution near to the HCl, it will give you dense white fumes of NH4Cl. NH4Cl, which is ammonium chloride, okay, dense white fumes are going to be seen when ammonia comes in contact with HCl. So that becomes a test for HCl and also for ammonia in a way. And also it is seen that if you take AgNO3, that is silver nitrate solution, when you take silver nitrate solution is going to give you a curdy white precipitate of AgCl. So silver nitrate gives you silver chloride, which is a white colored PPT. Curdy white colored PPT is going to be formed when this AgNO3 comes in contact with HCl. So HCl with AgNO3 will give you AgCl. This AgCl is a white curdy precipitate which is insoluble in HNO3. HNO3, barabar. The next is hydrogen sulfide. Now hydrogen sulfide has got a very peculiar, it is colorless but it's got a very peculiar smell, that is a rotten egg smell, and that is one of the most important identification point of H2S gas, that it is going to give you a rotten egg smell. So again it turns the blue litmus red, and here you can see that the tests which were there for sulfur dioxide in case of KMnO4 paper and K2Cr2O7 paper solution, the same tests are going to be holding true even for H2S. So that's why H2S और SO2 के बीच में अगर कुछ करना है, आइडेंटिफाई करना है, तो SO2 lime water turns milky, but here H2S doesn't turn lime water milky. But H2S, when it is going to be reacting with potassium permanganate, it is the pink color is going to become colorless, the same as in case of SO2. Similarly, acidified potassium permanganate turns orange color to green, which is also the same as that of SO2. The above tests are answered also by SO2. But in case of H2S, yellow particles of sulfur are seen, and the solution is hence not clear colorless or clear green respectively. So yeah, so there is a difference in the precipitate what is going to be formed over here by the KMnO4 and the K2Cr2O7, because there will be small yellow dots of sulfur which will be reformed. Apart from that, you can also have one more kind of reaction with lead acetate paper. So lead acetate paper will become silvery black. Okay, lead acetate paper, which is colorless, becomes silvery black when it comes in contact with H2S. So that's another important way of identifying H2S. The next kind of a gas is nitrogen dioxide, NO2. Now this nitrogen dioxide can be identified by the color because it is reddish brown in color. The reddish brown color and the irritating odor can also be one of the identification way of identifying the NO2. It will turn the blue litmus red. But apart from that, if you want to find out any method to identify it, you can use iodine, that is violet vapors of iodine and potassium iodide. From potassium iodide will be liberated. So you can see that when you take potassium iodide and react it with NO2, it is going to give you the violet fumes of iodine. So violet fumes of iodine are going to be formed when Ki, that is potassium iodine solution, is going to react with NO2. Secondly, it is dissolved in cold water to give mixture of nitrous and nitric acid in solution, which will turn blue litmus red. So that's another way of identifying the thing, because NO2 plus H2O will give you HNO2 plus HNO3. So hence NO2 is mixed as called as a mixed acid anhydride. Final gas over here is the ammonia gas. So ammonia gas is a basic gas. This is the only gas which is basic in nature. All others were neutral and acidic. So in case of basic gas, the only one is ammonia. Ammonia is colorless, but it's got a pungent odor. So pungent odor of ammonia is there, and it will turn, of course, the red litmus blue, not blue red, red to blue, because it is alkaline in nature, or it is basically basic in nature. The test over here, as I told you earlier also, HCl के साथ में जैसे NH3 था, वैसे ही NH3 के लिए we are going to take a glass rod dipped in HCl. It will give you dense white fumes of NH4Cl. So first thing is that gives dense white fumes when a glass rod dipped in concentrated HCl acid is brought near ammonia gas. Another thing is on passage through copper sulfate. If I take copper sulfate and I am going to pass it through ammonia, it will be fine that you are going to get a pale blue precipitate. Okay, so ammonia is going to be here, ammonia NH3 is going to be dissolved in water and formed into NH4OH. So you are going to use it in a NH4OH format and then going to react it with copper sulfate. You are going to get a pale blue precipitate initially, and if you add some more amount of NH4OH into it, it is going to give you a inky blue solution. So that's a deep blue or inky blue solution. So on passage of copper sulfate solution, it gives a pale blue precipitate, and on passage of excess ammonia, the pale blue precipitate dissolves to give you deep blue or inky blue solution of complex salts, tetraamine copper sulfate. Also, there is one more thing, and that is the Nessler's reagent, which is K2HgI4. The Nessler's reagent, which is colorless, will turn pale brown or gives a reddish brown PPT on passage of ammonia. So this is the test for the ammonia, that Nessler's reagent, which is colorless, will become reddish brown or pale brown in color. So that is the test for ammonia. So these were the 10 different gases what we need to identify. So that was the identification of the gases. Now we move on to the action of heat. So what happens when a particular thing is heated? So over here when you are heating certain things, so first of all is CuCO3. So when CuCO3, now we know that any carbonate, whenever any carbonate is going to be heated, it is going to give me oxide of the metal plus carbon dioxide. So what I'm going to get will be CuO plus CO2. This is a standard reaction what I'm going to get over here. But what is important over here is the color changes. Here this is light green and this is black. So the color change over here is very important, because they can not only ask you what happens when, but also they can ask you as an observation. Okay, what do you observe when copper carbonate is heated? So you need to say that black colored copper oxide is formed and carbon dioxide is going to be released, a gas will be released which will turn lime water milky but does not have any effect on KMnO4 or K2Cr2 solution. This is precisely the answer what you will be writing. The next could be zinc carbonate. Again the same thing, ZnCO3 will give you ZnO plus CO2. Again the color changes are very important. This is white in color, but here the color is such that when this is hot, it will be yellow when hot and it will be white when it is cold. So if it is cold or hot, it will be of different colors. So ZnCO3, that is zinc carbonate, when it is heated will give you a yellow colored PPT when it is hot and a white colored PPT when it's cooled down or cold. Along with that, there will be an evolution of the gas which is going to be colorless, but it is going to turn the lime water milky but has no effect on KMnO4 or K2Cr2O7 solution. So that's what they are written over here also, turns yellow on heating, and carbon dioxide is colorless, odorless, nature slightly acidic to litmus. Lime water turns milky but no effect on KMnO4, where zinc oxide formed is yellow when hot and white when cold. So deduction is the white powder is zinc carbonate. The next is washing soda, that is Na2CO3 Na2CO3.10H2O. This is washing soda. The washing soda, it is just going to become, it is going to be not completely dehydrated. So it is Na2CO3.H2O plus 9H2O. So that is the only thing what is going to happen over here, that the washing soda mein, uska water crystallization is going to be lost. So what will happen is that original color is white and the color of white will be remaining on heating, and the water vapor will be formed which will be colorless liquid neutral to litmus, turns cobalt chloride paper blue to pink. Residue is white sodium carbonate informed, and the white powder is washing soda. So that is for washing soda. Similar thing is for copper sulfate crystals. So CuSO4.5H2O is the blue colored crystal of copper sulfate, which on heating will turn into white colored anhydrous CuSO4. So white colored anhydrous CuSO4 will be formed and H2O is going to be given out. So over here, now here there is one more important thing, that is if you strongly heat it. Now here, so CuSO4 you can have two effects. So one is CuSO4.5H2O, where it is just heated, slightly heated, and thoda sa ye hua. In that case, it will just become CuSO4 plus 5H2O, wherein this will be white in color, white colored anhydrous. Whereas this one was blue colored crystal. So that is the difference over here. So the blue colored crystal is going to turn into white, and you can test for H2O over here by cobalt chloride paper turning pink. So that is one part. And in case you strongly heat it, so if you strongly heat this, then CuSO4 is going to turn into CuO plus SO2 plus O2. Okay, this is what is going to happen when it is strongly heated. So when it is strongly heated, the black colored residue of CuO is going to be formed, SO2 will be formed. SO2 का टेस्ट हम लोग को मालूम है क्या है उसमें अंदर lime water term milky as well as affects the KMnO4 or K2Cr4 paper by change in color, and O2 will rekindle the glowing splinter. So accordingly you will see that blue hydrous color changes to white anhydrous on heating. On strong heating forms into black residue, and gas evolved will be water vapor initially or SO2 and O2, and sulfur dioxide is colorless, acidic to litmus, turns KMnO paper pink to colorless. Oxygen colorless, odorless, neutral to litmus, rekindles the glowing splinter, and initially anhydrous, and on heating copper oxide is going to be formed, which is blue powder is copper sulfate. The fifth one is zinc nitrate. So zinc nitrate, again the same thing, we are going to have it as 2ZnNO3 twice is going to get heated to form ZnO plus NO2 plus O2. So this is the reaction what is going to be found when you are going to heat nitrates. So nitrates, whenever heated, you are going to get metallic oxide plus NO2 plus O2. Remember this thing, nitrates, when you, except for potassium and sodium nitrate, they are going to form into nitrite. The NO2 will be formed, but बाकी सब जगह पे NO2 form होगा ही होगा. Okay, so here we can see that same thing here, yellow when hot, cold when, white when cold. NO2 reddish brown fumes of the gas. So first of all, white in color turns yellow on strong heating, and NO2 and O2 which will be formed, NO2 reddish brown in color, acetic to litmus, turns acidic by ferrous sulfate solution brown. Oxygen colorless neutral, rekindles the glowing splinter, and residue is silk oxide which is yellow when hot and white when cold. So hence the reduction is that it is the zinc sulfate or zinc nitrate. Similarly, copper nitrate, exactly the same condition, only thing is that you are going to get CuO instead of this. So CuO, what is going to be formed will be black in color. So otherwise, way nitrogen dioxide is going to be formed, oxygen is going to be formed. So exactly the same reactions over here. It will be CuNO3 twice will give you CuO plus NO2 plus O2. So this is black in color. This was yellow and white, hot and cold. So this was about copper nitrate. Copper nitrate, it was blue. It is going to turn black on heating. NO2 will be reddish brown, and oxygen will be colorless and rekindle the glowing splinter. So residue will be black colored copper oxide, which will be turned blue powder is nothing but copper nitrate. The next we see is lead nitrate. Similar condition again. What we have is lead nitrate will become lead oxide plus nitrogen dioxide plus oxygen. Same kind of reaction. PB के बदले आया तो PBO हो जाएगा, PBO plus NO2 plus O2, and you are going to get white crystalline. Color change will be yellow on heating, dissipates and melts, and then NO2 will be reddish brown, oxygen rekindles glowing splinter. So it is white powder. What we have got is lead nitrate. So litharge is formed on strong heating which fuses with the glass. So this is one important thing, that residue जो litharge जो form होगा, that is PBO which is formed over there, which is called as litharge, which is yellow in color, is going to stick to the glass. So that is one more kind of a observation what you see over here. The next is ammonium chloride. Ammonium chloride on heating is going to form into ammonia plus HCl. So we had seen the reaction of NH3 plus HCl giving NH4Cl. वो reversible reaction है. So NH4Cl on heating become NH3 plus HCl. So two colorless compounds are going to give you a white colored crystal solid, which is ammonium chloride. So sublimes, on heating it sublimes and evolves two gases, one basic gas and one acidic gas, NH3 and HCl, which on cooling combines to form ammonium chloride again. So no residue is left in the test tube, and the white powder is ammonium chloride. Iodine simple vapors are there. So iodine vapors are violet in color. So when you are heating it, it's just going to give you vapors of iodine. So it is a sublimable substance, so it sublimes, and the violet color vapors are going to be formed. Test will be fumes turns silver nitrate paper yellow, no residues, and crystal is iodine. Ammonium dichromate, which is orange in color. Now this is important. Ammonium dichromate, the last one over here is ammonium dichromate. So If you take ammonium dichromate, it is orange in color, that is NH4 twice Cr2O7 is going to give me as Cr2O3 plus 4H2O plus N2. So this over here, this is orange in color, but on heating, this what we're going to get is green in color. So the change in the color will be from orange to green. So original color orange, on heating decomposes violently to flash of lights, leaving a voluminous green residue. So gas evolved, water vapor initially, and then N2 is there. The green chromic oxide on strong heating is what is the residue, and the orange powder is nothing but ammonium dichromate. So this was your ammonium dichromate as the last compound, which was for heating effect or effect of heating. Now the thing is about the acid addition of dilute sulfuric acid into certain things. So first thing is that we very well know, hydrogen chapter mein padha tha, that metal plus acid will give you metallic salt plus hydrogen. So first is that if you take an active metal and sulfuric acid, it is going to give you the metallic sulfate, and hydrogen gas is going to be evolved. So that's the first thing. So metal, when it reacts, so if I take Mg plus H2SO4, it is going to give me MgSO4 plus H2. So this is the reaction what I am going to get. So hydrogen gas is going to be released, which will burn with a pop sound and a bluish pale blue flame. So that is identification for hydrogen in this case. Secondly is carbonates. So if I am taking a carbonate, so suppose I have taken a carbonate, that is I have taken Na2CO3 and I am reacting with H2SO4, which is again dilute in nature. So dilute H2SO4 if I take, it is going to give rise to NaSO4 plus H2O plus CO2. So a carbonate, when it is going to react with an acid, it is going to give me salt plus water plus carbon dioxide. Any carbonate, when it is reacted with acid, it is going to give me salt. NaSO4 to NaSO4 is a salt. So NaSO4 is going to be formed plus Na2SO4. Na2SO4 will be formed plus water plus carbon dioxide. So this is the simple thing. Even if I take bicarbonate, even if I take NaHCO3 plus H2SO4, it is going to remain the same. It gives me the same thing, Na2SO4 SO4 plus H2O plus CO2. So whether I take a carbonate or a bicarbonate, the end result will be that I get a salt plus water plus carbon dioxide. The next is sulfides. So if I take a sulfide, if I take Na2S and react it with H2SO4, again over here you are going to get Na2SO4 plus H2S. So the reaction will be that whenever a sulfide of a metal is going to be reacting with dilute sulfuric acid, it is going to give me salt plus hydrogen sulfide. Now, hydrogen sulfide is the one which has got that rotten egg smell. So the colorless gas is evolved with a rotten egg smell, and the gas turns moist lead acetate paper silvery black and lead nitrate solution from colorless to black. So that is the identification for H2S gas. So any sulfide, when it comes in contact with acid, it is going to give you salt plus H2S. Lastly is a sulfite. Okay, we are talking now about sulfite, that is Na2SO3 plus H2SO4 will give me it is going to give me Na2SO4 plus H2O plus SO2. So again, the reaction over here is the same thing, that a sulfide, so this was a sulfider, this is a sulfiter. Okay, so that's the difference, IDE, ITE. So in case of sulfite, it is going to become a sulfate plus, that is salt plus water plus sulfur dioxide. And sulfur dioxide, we know that it is going to be turning the lime water milky plus the KMnO4 papers solution में और K2Cr2 solution में it is going to change the color from orange to green and for pink to clear. So colorless gases evolve with a suffocating odor. Gas turns lime water milky and turns acidified potassium permanganate from pink to clear, and the gas turns acidified potassium dichromate orange to clear green. So this is the reaction what takes place when an acid reacts with these things: metals, carbonates, bicarbonates, sulfides and sulfites. Okay, simple reactions. Just remember this thing so that you can understand chemistry much better. Finally, the flame test, that if I want to identify that what is the metal present over there, then I will have the flame test. Now flame test के लिए करते क्या है, तो you are going to take a thin platinum wire and thoroughly cleaned and then heated in a non-luminous flame in a burner. So you are going to take a thin wire, that is a platinum wire will be there, and then platinum wire को हम लोग को heat करेंगे on the burner, और heat होने के बाद में, so when the wire imparts no color in it, then you are going to dip it in the HCl solution. कौन से HCl में डालेंगे, and then you dip it into the substance which you need to identify. Suppose मेरे पास एक salt है, like it is like sodium chloride is there. Okay, sodium chloride है मेरे पास, तो मैंने क्या किया, ये वायर लिया, उसको हीट किया, हीट करने के बाद उसको HCl में डाला, HCl में डालने के बाद में ये NaCl में डाला, एंड उसके बाद उसको फिर से हीट किया. द वायर इज देन इंट्रोड्यूस इनटू द नॉन-ल्यूमिनस फ्लेम एंड द कलर इम्पार्टेड इज नोटेड. सो उसके बाद जब मैं हीट करता हूँ, एट दैट टाइम व्हाटएवर इज द कलर ऑफ द फ्लेम इज गोइंग टू आइडेंटिफाई द metal which is present. So if the color which is going to be there is golden yellow, it is going to be sodium. Okay, golden yellow तो sodium. और वही चीज हम लोग अगर ब्लू कलर के ग्लास से देखते हैं, दिस इज अ मेथड ऑफ सीइंग इट. सो इफ यू आर सीइंग इफ अ ब्लू कलर ग्लास, it is going to look as a pale yellow. Okay, it will not be golden yellow, it will be pale yellow. Then there is sodium. If the color is lilac and in blue glass violet, it is potassium. And if it is reddish brick red and it turns into pale green when in blue color, it is calcium. So this is how you can identify potassium, calcium and sodium by the flame test. Golden yellow, sodium. Lilac, potassium. Brick red, calcium. Okay, so that is about the flame test. You can see the figures which are over here, the colorful figures are here. जैसे हम लोग ने hydrated salt को heat किया तो वो blue colored crystal became white powder. Then hydrogen evolve जो भी किया तो उसमें active metal is going to give you rise to the hydrogen, so glowing splinter जो है वो बंद हो गया. वैसे ही oxygen लिया तो वो glowing splinter जो है वो rekindle करने लगा. The next one is carbon dioxide. You can see the KMnO4 paper which is just going to have no effect on it. KMnO4 paper, neither K2Cr2 gives you paper, but the lime water turns milky. SO4 में it got turned to colorless and green. So you can see the change in the color. They are shown very clearly in the figures over here, and along with the lime water turning milky. Also chlorine के अंदर भी you can see the litmus paper getting bleached and the starch hardened paper becoming black. Then HCl में we can see that ammonia and HCl gives you dense white fumes. H2S में it is the silvery black हो जाता है acetic paper, and the reddish brown fumes are going to be seen in the nitrogen dioxide, which is going to turn the paper Ki paper brown, and then the ammonia is going to turn the red paper blue and is going to give you dense white fumes. Right, so all these are there. Then the heating effect के भी दिया है. Mercury oxide is going to give you a silvery deposit. The red lead gives you a yellow thing which is fused to the glass, that is PbO. And lead oxide gives you yellow again. Then copper carbonate gives you a light green which is turning black. Zinc carbonate white to turn yellow. Washing soda white to white only. But copper sulfate from blue to white, and then it is going to be strong black. Zinc nitrate from white to yellow. Copper nitrate from blue to black. White to yellow, lead nitrate. And finally the heat of ammonium chloride, it is just going to get sublimed. Iodine just gets sublimed. Ammonium dichromate orange to green हो रहा है, and the flame test count in a golden yellow and lilac and red color का flames दिया. So this is about the chapter, that is the practical chemistry. Not exactly a chapter, but very important for you to understand, because they are based on the basics or the roots of the chemistry. So that's why you need to understand these very well, so that it's more easier for you to understand chemistry in a totality. So that's the end of the practical part of chemistry for standard 9. Okay, thank you.